Hello friends, we are discussing chemical kinetics, and in chemical kinetics now derivation of rate constant of third order reaction with equal initial concentration. So for that derivation, first what we are doing, consider a general chemical reaction with order 3 or third order reaction. Consider direct third order reaction, order 3. So two way we can consider, because equal initial concentration is there. Either you can write 3A gives product, or another way we can consider A plus B plus C gives product. So in this case, or this case also, no problem. Initially, when time is 0, as usual, we have discussed product was not formed, so 0. Concentration of product is 0. Late concentration of the reactant A is small a, but it is equal initial concentration. So if concentration of reactant A is A at time 0, means initially, so equal initial concentration means if this is A, then this should be A, this should be A. So all three are A. So this way. At time t, let X be the concentration of product. Then concentration of A is A minus X, concentration of B also A minus X, and concentration of C also A minus X. Similarly, here also 3 times A minus X into A minus X into A minus X. So either this reaction or this reaction. What is difference? Here 3 same reactants. Here 3 different reactants, but equal initial concentration. So such reaction we have considered. So then we have to apply the rate law. So by rate law, rate of reaction is directly proportional to concentration of all reactant A into reactant B into reactant C, and that is A minus X raised to 3. So we can write this way. It is third order reaction. Rate of reaction is directly proportional to A minus X raised to 3. Therefore, rate is equal to K3, third order rate constant, into A minus X bracket raised to 3. This 3 is experimentally determined order, third order. So this is your equation number 1. Now by definition of rate of reaction, so rate is equal to dx by dt. So this we know that. Now from equation 1 and 2, left side is rate, so right side automatically it will be equal, and therefore we can up to here write properly and go ahead. So therefore from equation 1 and 2, what we can write? This is 1 and this is 2. So from equation 1 and 2, we can write K3 into A minus X bracket raised to 3 is equal to dx by dt. Now I want to remove this derivative, and how we can remove derivative? By taking integration. But what is necessary condition to take integration? First, similar variable should be similar side. So dx is the variable, so take this one this side. A minus X should be right side. So therefore K3, take this dt here, so it was divided in that party, in this party it will be multiplied, which is equal to dx upon A minus X bracket raised to 3 was multiplied in left hand side, but if it is going in right hand side, it should be divide, and this is your equation number 3, we don't want derivative, so take integration of equation 3. So take integration of equation 3, integration of equation 3, then we have to apply limit there also, k3 dt. So limit for time is 0 to t as equal to this. I can write this way, a minus x bracket raised to 3 into dx. So this dx I have written here and it is 1 upon a minus x. So instead of here I have written there, and limit is when time was 0, product was 0. X is what? Product. And when time was t, product was x. So this way we can write here and solve directly here. K3 is constant, so take K3 outside the integration, 0 to t into dt is equal to 0 to x. Now only one function is there. Previous case two function, then it was difficult part. It is not difficult part now. Only one function, a minus x, x variable, a constant is there. You can write this a minus x. This denominator I want to write at the numerator. So how we can write? 1 into a minus x. Here positive side, if you are taking denominator to numerator or numerator to denominator, sign of power will be changed. So we can write this way. So here positive side, here minus 3 into dx. So this is, you can say, your equation number 4. Now why I have done this? Because we have integration formula. So which integration formula? You can write here, since integration of this formula we are applying, x raised to n dx is what? X raised to n plus 1 upon n plus 1. So this is the integration formula. And if such function is there, a minus x, it is not just x, it is a minus x. So remaining function, by that function we have to divide to the that numerator by derivative of this one. So that we have to divide there. So that we can do, we can apply. Therefore in equation 4 we are applying this formula, by this formula, or you can go this way. Therefore in equation 4 this is your equation 4. Therefore in equation 4 k3 into integration of dt is t. So 0 to lower limit 0, upper limit t. Integration of derivative. Cancel, only t will be left. Then integration of a minus x raised to minus 3. So there we are applying this formula. So a minus x raised to minus 3 plus 1, because n is what? Minus 3, upon minus 3 plus 1. This is one part, into d by dx of a minus x. This is important. If only x is there, not necessary to divide because value is 1. But if a minus x such function is there, in that case we have to divide by derivative of that function. Lower limit here 0, upper limit is x, and therefore k3 t is equal to, we can solve this one, a minus x raised to minus 3 plus 1, so it will be minus 2 upon here minus 3 plus 1 minus 2 into derivative of a is constant, so 0. Derivative of a is 0 and derivative of minus x is minus 1. So 0 minus 1 will be minus 1. Lower limit 0, upper limit x. So this way we can simplify. And again, next we have to subtract this upper limit. Again we will simplify, that will be better. So this is what? This I am taking a denominator, minus 2 into minus 1 is what? 1 upon 2 into, this is a minus x at numerator raised to minus 2. So at denominator it will be a minus x bracket raised to 2. So bracket square. So 0 to x. Now again for simplification here 1 by 2. Constant term is there. You can take it out. Therefore k3t is equal to 1 upon 2. What will be left? 1 upon a minus x bracket square 0 to x. Now we will apply upper limit minus lower limit. Therefore k3t is equal to 1 upon t. Upper limit, instead of x we have to put x, but already x is there. So 1 upon a minus x bracket raised to 2 minus 1 upon, instead of x, lower limit, we have to put 0. So a minus 0 bracket raised to 2. So a minus 0 is a, and you can write by solving this one. Therefore up to here note properly and go ahead. So k3t is equal to, simplify this one, and k3t is equal to, therefore k3t is equal to 1 upon 2 into 1 upon a minus x bracket square minus 1 upon a minus 0 a. So a square. So we can write this way. Take t that side, therefore k3 is equal to 1 upon 2t into 1 upon a minus x bracket square minus 1 upon a square. So this is important equation of rate constant of third order reaction. So you can note this is our equation number 4. Again we can solve this equation. K3 1 upon 2t is equal to, how to solve? Just by cross multiplication, LCM. So multiply by a square here, cross multiplication, minus a minus x bracket square upon a square into a minus x bracket square. So multiply at denominator both this denominator and cross multiplication. Again solve this one. So k3 is equal to 1 upon 2t a square minus, solve this one. So inside the bracket, a minus b bracket square is what? A square minus 2ab plus b square. So apply that formula, a minus b square, a formula there. So a square minus 2ax plus x square upon a square into a minus x bracket square. Therefore k3 is equal to 1 upon 2t. Now take this minus side inside the bracket. So a square minus minus become plus 2ax minus plus minus x square upon a square into a minus x bracket square. This a square can be cancelled, and remaining equation we can write. I am writing up to here all the points, see properly, and write this remaining equation. K3 is equal to, so what will be left? K3 is equal to 1 upon 2t inside the bracket 2ax minus x square upon this a square into a minus x bracket square, or this a square is constant, so you can write this one another way also. So k3 is equal to 1 upon a square, right here 2a square t into what is left 2ax minus x square upon a minus x bracket square. So this is our equation number 5. Observe equation 4 and equation 5. Both equations are same only. This is after some calculation we are getting this equation. But both the equation 4 and equation 5 are the equations of rate constants of third order reaction with equal initial concentration. So K3 is equal to 1 upon 2T in bracket 1 upon 2 a minus x bracket square minus 1 upon a square, where a is initial concentration and x is concentration of product at time t, and K3 is our rate constant or specific reaction rate or velocity constant of third order reaction. And another way, it is another form. K3 is equal to 1 upon 2a square t in bracket 2ax minus x square upon a minus x bracket square. So this way we can derive the equation of third order reaction. So remember the steps. First we have considered a general third order reaction with equal initial concentration. Either 3a gives product or a plus b plus c with equal initial concentration gives product. That general reaction we have considered. Then we have applied rate law. Then after applying rate law, by definition of rate equation we have written, and once rate equation is there, rate law is there, both the equation we have equated, and in it equated equation that derivative term is there. To remove the derivative we have taken integration, and after taking integration and applying the knowledge of integration we are getting this equation. K3 is equal to this, that is equation 4, and K3 is equal to 1 upon 2a square t in bracket 2ax minus x square upon a minus x bracket square. So remember these steps and remember this derivation. This derivation is very important in order to semester examinations. So thanks to all of you and have a nice day.